Good morning, my name is Juan-Pablo, and today I will discuss about the multi-fidelity gray box models for the computational risk assessment of cyber-physical systems. Now, a cyber-physical system appears when we combine cyber and physical elements. Nowadays, this coupling of components is becoming critical and more used in large-scale systems, such as smart grid, telecommunication networks, infrastructure, such as transportation and water supply. Now, assessing the risk of these systems is therefore essential. And for that, performing risk assessment has become one of the most fundamental steps in the deployment of cyber-physical systems. Nevertheless, this coupling of components creates complex interdependencies that make very difficult to assess the risk in these systems. Indeed, decomposing a cyber-physical system into subsystems to analyze and understand why they fail is sometimes impossible. Therefore, computational risk assessment is the way to go. To perform computational risk assessment, we do simulations. And for that, we need a model of the cyber-physical system. However, this model tends to be very expensive. And also the external stimuli, that is the element that affect the cyber-physical system, are too many. Of course, these two elements do not go well. And that's why we are trying to create a new solution based on gray box models. A gray box model is one that combines physics and data-driven models. And in this case, we can see a cyber-physical system as a combination of agents that communicate all among each other. We can see the cyber-physical system tends to be a hierarchy of elements that control one another. And therefore, what we do is to divide all the cyber-physical system into all of these components. And the idea is to replace them with some of them with data-driven models. Now, of course, one of the main questions is, how do we do these substitutions? How do we choose what are the models that we want to turn into a data-driven model? And that's the key question of my PhD. For that, we are resorting to using rare event simulations to obtain relevant responses of the cyber-physical system. We're developing an approach based on value of information to select strategically what are the components that we are going to substitute, and also, in the end, provide an optimal substitution plan that enables us to obtain a gray box model of the cyber-physical system that is interpretable, low fidelity, and easy to create. Thank you.